are going to use this for every single programming question in today's test. It is every bit of it, alright? So please make sure you know this inside and out, alright? Essentially, all you do is write the word print, being very careful not to use capital letters, and then anything that appears in between these brackets will be printed out to the viewer. The only thing to be conscious of is this bit, the speech marks. If you put speech marks, it will print out the message that appears exactly as it's written. If you don't put speech marks, it's a variable. So without those speech marks there, this needs to be the name of a variable, which we're calling upon, which we'll go through in a minute. But that's the only thing to be conscious of with that first one. Alright, print, brackets, then whatever you want, either a variable name, say number or whatever, and then if you want a sentence, use speech marks. Alright, that's the only one with that one you'll need to know. Okay, the next slide is just defining variables. So a variable is just a location somewhere in the memory that uses the name that you're giving it. That's a complicated way of describing it, but essentially you're saying this part of the memory, so whatever data I'm going to make, I want you to put it in that part. Just so basically you say variable 1 store it here, variable 2 store it in this place, variable 3 store it in this place. Doesn't matter what data is in those different variables. It just means that when I say variable 2, it goes to that place where variable 2 is stored, picks it up and brings it back to you. That's all a variable is. It's a defined memory location. Doesn't matter what the data is. The way you define a variable is this. We just name it, so we have to give a variable a name, equals, and then the value of that variable. So it could be anything. Variable 1, look, you can see is a number, number 2. Variable 2, I've made the word Dave. Alright? That's essentially how we define variables. We can then use them same way we did before. Look, so the viewer can see it. The user cannot see this happening. So as far as the viewer can see, this is happening in the background. They cannot see any of that happening. They can only see when the information is output to them, right? Which is why you can see really clearly, look, the results there are only the green bits you can see. So the prints, they print out the results. All right, that's it. So we have two different print commands here. The first one, this one, print, and then we're doing the variable times by the variable again. So 2 times 2, so the result will be 4. All right. The next one, we're going to do print your name is plus variable. I've messed that up. So the result should be your name is Dave, because the variable is Dave, variable 2. So it should say your name is Dave. I've messed that up and I don't have time to fix it. Sorry guys. It should say your name is Dave in the result down the bottom. Alright, so it should say here I'll correct that. It's hard to write in a thing. Your name is. There you go. That's what it should say. Your name is Dave, rather than my stupid result. And that is then calling upon variable 2, which we've defined the value of variable 2 as Dave. And that's why that's doing that. Next slide is about data types. Python likes to know basically what to expect. That's what data types are. So if we want to give it a word, Python wants to know that. If we want to give it numbers, Python wants to know that. There are a range of data types we need to know. They are listed here. Alright, the most important ones are integer, which is a whole number. Whole number, that's important because this one, we call this one real or float. It's either real number or a floating point number, but basically that's a decimal number. A string is the most common we'll use, which is basically a word or a sentence. A string of characters is the official name. Now, these are the bits here. Oh, Boolean is just true or false. Sorry, I should say that as well. But these bits here are important. So, these are what we call the notations. Now, the notations are like the short, you can't read that. Try a different colour. The notations are the shorthand. So, if instead of writing integer, I'll write int. Instead of writing string, I'll write str. Instead of writing float, well, I'll write float. That's a stupid one, but you get the idea. Now look, this is our program. Variable 1 equals 2. Variable 2 equals Dave, just like before on the previous slide. We're going to print variable 2, which is Dave, plus you have, and then a pound sign, plus, and this is the bit here. Now, because basically what we're doing is we're mixing numbers and letters together. Python does not like that. It doesn't like it at all. It doesn't like you mixing data types together. So what we have to do is we have to do something called casting, which is where we tell Python, and that's this little bit here, the str bit, we tell Python that we want you to treat a data type like another data type, but just for a little while. So basically we're saying we know this is a number, we know variable 2 is a number, but I want you to treat it like a string just so I can put it in this sentence. Otherwise it'll bring an error and basically say you can't concatenate string and integers or something like that. So basically saying you can't combine string and integers. But if I say nope, treat this as a string, treat variable 1 as a string, so instead of using the number 2, pretend it's a character, and then it can put it in the sentence, which is why our result will have a mixture of variable 1, sorry, the first variable, variable 2, which is the word Dave, with our number here, which is variable 1, and it can combine them in a sentence because of this, and that's called casting, treating one data type as another. Right, next essential one is inputting data. So in every question, there'll be a bit where you're going to ask the user to enter some data. This is it, really. This is how you do it. So it's called inputting. You're basically saying, answer this question and I'll save the data as a variable. So this is my best example, the easiest one. I'm making a variable called name, and I'm basically saying, can you input, the user input an answer to this question? So it always goes the same way. Variable name, the word equals the word input, and then the question in speech marks and brackets. All right. The next one, look, you can see is number. Again, though, look, equals input, but this time my question is different. I say, enter a number. I can then use them in print variables. So whatever the user puts as this answer will then be applied here. So the user here, whatever they type for their name here, will go into the print of this. So the answer, if I put my name as my input here, the next bit in the result will just be Mr. Brown. And lovely writing, I'm sure you all agree. So Mr. Brown then would be the name. Now the number, you can see I've used my casting like the previous slide. My number, whatever I enter to there, will then go into this sentence because I'm printing it out. Now remember, the user will only see. So it'll then print out your number is, I won't do the whole thing. It'll then print out that full sentence. Whatever number I put into that first question, it will then print out, I don't know, if I put in number 2. I don't know, I'm just guessing. Alright. This is the bit that appears to the user. So the bit here is the question that appears to the user. So it'll basically, the program will put that up on the screen. The user then has to type in an answer. Whatever they type in will be saved as this variable or this variable, and then you can use it. You can call upon those variables like I've done here with these print commands to output. And that's how we use inputting, but basically it's that. Just remember, whatever you import, you can then use that data for whatever you want and then output using prints. Right, the next one's a fancy term, but it basically means a test. We call them control structures, but it's just a test on some data. That's it. That's all it is. It's a test on data. Most common one is this. It's called an if statement. We take some data from the user, just like we always do. So this is me asking the user to enter a number. Look, you can see number equals input, enter a number. The user's number is then tested against some criteria using this thing here. All right, it's called an if statement. It basically says if the number is greater than 5, do this. So if the number is greater than 5, do this. And that's why we tab in. So tab is important because we're saying is greater than 5, so if this test is true, so if that test is true, in other words, the number is greater than 5, do this. If it's not though, Python knows to ignore it. So if the number is not bigger than 5, it just doesn't run that program. So if the number is not bigger than 5, it will ignore that part of the program because of this tab. Without this tab, it will just run it no matter what. So this tabbing in is really important. So we're asking the question, if the number is greater than 5, do this. If the number is greater than 5, it runs it. If the number is not greater than 5, it ignores it and pretends it doesn't exist and then moves to the next line. Okay, which is where this comes in. This is your next type of structure. It's just called an else. It basically means for everything else. In other words, if the number is not greater than 5, it'll print this. Now you can do the same thing twice. You could put if the number is greater than 5 or if the number is less than 5. That'd be fine. But your problem then is if the number is 5, it doesn't fall into either of those two tests. So else just does every other number. In other words, 5 and lower. So this will basically say every number that is not bigger than 5, if the person types that in, any number not bigger than 5, print this. And that's how a control structure or an if statement works. Alright? Right, your next thing is loops. Loops are condition controlled loops specifically. There's two types of loops, but the overall term is called iteration. Iteration is just a loop. That is it. That's all you need to know about. It's something that repeats itself over and over again. That's iteration. It's part of the program that repeats itself. This one's called a condition controlled loop. Alright, a condition controlled loop means it's going to test against a condition and it'll do the test over and over and over and over and over again until the condition is met. And I'll show you what I mean by that. So in the same one as we did before with the if, look, we ask for a number. But this time, instead of if, we're going to do while. While the number is less than 5. Right? We're going to basically say print the number. So we print out the number to the user so they can see it. We're then going to print out the message less than 5. And then, because otherwise, what would happen is this would print forever. If we didn't change the number, so you can see they need the data to change. If we didn't change the number, the value that the person's typed in is always going to be less than 5, which means this loop would just keep going forever, which means this would print infinitely forever, because if I typed in 2, 2 is always less than 5, so that means it would keep going. So this bit here, the change is vital. If we don't have some sort of change in a while loop, it'll just print infinitely. Alright, so what I do here is I take the number, so say I typed in 2, I'm going to say 2 is then equal to 2 but plus 1. So it becomes 3. So then the test happens again, so it goes back to the beginning of that bit. So 2, if I typed in 2, it becomes 3. 3, is it less than 5? It is, so I repeat the process again, but then we've got 3 as the number here, so 3 equals 3 plus 1. That makes 4. 4 is still less than 5, so it repeats again because it's still less than 5. And then it does it one more time, but now the number is no longer less than 5. So once we actually hit the number 5, we're not less than 5 anymore, in which case what it does is it ignores all of this indented stuff and it moves on to this next line. So as soon as the criteria is met, or is not met I should say, i.e. the number is not less than 5, so as soon as it turns to false, it moves on and ignores everything that's indented. So this indentation is key. Alright, but that's a while loop. Essentially, it's saying, I'll get rid of all this for you so you can see it. While the number is less than 5, keep looping, but add 1 to the number every time. That's what this one little bit's doing. Add 1 to the number every time. As soon as it gets to 5, so as soon as the number becomes 5, it knows to ignore it all because it's indented, and it moves on to this next part of code that's on the same level as it. Alright, and that's why indentation is really important for while loops too. Right, the next one's called a count controlled loop. It's the same thing as the other loop really, where it's going to keep going over and over again, but in this one we use a range. Okay, so in a count controlled loop we decide how many numbers it's going to test, or the range it's going to test I should say. So in this example, look, I use this. this, for I in range, and we put bracket 0, comma 5. All right, and what we're basically saying is, for I is a number, but you can put anything there. You can put 4x or whatever. It's basically saying we know that value is going to change. So I know that is not going to be constantly the same number. I know it's going to change. For every number in the range of, start with 0 and then go to 5, I want you to print the number. That's why, look, they need to be the same. So look, that and this need to be the same. All right. So what we're saying is, oh, I need my rubber, not that one. What we're saying is, for every single number, that's what the I is, remember, between 0 and 5, print the number. Now, this is important, but it is not inclusive, which means it won't include the highest number in your range. So it says between 0 and 5. That's the official denominator. For every number between 0 and 5, for I in the range of 0 and 5, which is why it'll print 0, because 0 is in the range 2, 3, 4, but then it will not print the number 5. Alright, so if you wanted to print up to 5, you just make your range 6, and then it'll print 0, 1, 2, 3, 4, 5. Alright, but that's the count controlled loop. And the best one is the for I in range. Remember, the I doesn't matter, it could be anything, it could be X, but as long as it's the same. So as long as that I or that X or whatever is the same as the one you print in, that's how it works. And that's the count controlled loop. Right, we'll move through this one a bit quicker. I know, I'm sure you're all rolling your eyes already by now, but an array is just a list. It's just a list of data, a series of data. Now, first thing to note about an array, all the different data are separated by commas. That's important. Each value is separated by a comma, because this array can hold anything. It can hold numbers, it can hold names like mine here, doesn't matter, but each different value is separated by a comma. Now the first value in our array is always given the number 0. So this, Jim, is at position 0, Bob is at position 1, Big Shaz is at position 2. So when I print out the students, which is my variable for my array, my variable name, I set a variable name for my array just like I do everything else, but I'm going to start at position 2, and I'll change my pen colour. Position 2 is the furthest one, and it goes look to position 2. Position 1 is then Bob, and then position 0 is then Jim. So if I just run this program, this is what it'd say. This all happens in the background, so I can't see any of this happening, but then the things that I output to the user will just be first Big Shaz, because it goes right, print from my students list, position 2, 0, 1, 2, right, print the word Big Shaz. Position 1, print the word Bob. Position 0, print the word Jim. And that's how arrays work. And this data can be names or numbers or whatever, doesn't matter. But it's those positions that are key, and the square brackets. Square brackets mean arrays or lists. That's important. So notice where the square brackets are here. I'll find another colour. Here, look, and the square brackets are here. Alright, to make our arrays. So square brackets means arrays, just so we all know. Just notice where they are and how important they are. Starts at position 0, so reminder again, that's 0, that's 1, that's 2, and just remember the importance of those square brackets. They're really, really important, because otherwise it's not an array. Alright, square brackets mean list. Right, this is a little function, an arithmetic operator we call it. An operator, it sounds silly, but it's like maths. It's like a plus or a minus, the same thing. First one's div. Div we call floor division, and it's basically the highest whole number of whole numbers that can fit within it. I'll give you my example. If I do 10 and then div or floor division 3, there are 3 threes in 10. So 3 is 1, 2, 9, then it goes 12. So that's too much. So there's 1 3, 2 3, 3 threes. That is what we mean by the floor division or the floor number, which is why, look, when I print the floor number, it prints out the number 3. Now the next one is called modulo or mod, and it's the other side of this. So when we do modulo, it basically finds us the remainder. So here's how we actually run modulo. Look, it's with the that's how we do it with the percentage sign, I should say. With div, it's just 2 slashes like that. When we run modulo, all it does is it finds the remainder. So if I do div and I figure out that, well, the biggest whole number of 3's, so if I do 10 modulo 3, I know that the biggest whole number of 3's, look, is 9, right? So basically then what it does is it works that out for you and says, well, 10 minus 9 equals 1, so my remainder will always be 1. So therefore, 10 modulo 3, and I print that out, will give me the remainder, which is 1. And that's how modulo and div, or floor division, work. Right, a function. A couple of things to note about a function, but the easiest thing to know is they're just for blocks of data that you're going to use over and over again. They're dead useful. So I don't have to write them multiple times. I can just call upon my function for programs that I'm using a lot. What that means is I don't have to rewrite commands over and over, and also I don't need to proof check each individual block of code. I can do it once and then just use my function instead of calling on things multiple times. Now the way you define a function is dead easy. Just write the word def for define and then write your function name. That's it. These brackets and then a colon just to say this is what I want my function to do. Now again, anything we then tab in becomes part of that function. So when we tab in, look, everything that's tabbed in becomes the action on that function. So if I just put this is now a function, print this is now a function, when I run my function or call upon my function, which is this bit here, the function 1, just put the name of the function in and it will run it at any point in your program. So I could write a million other lines of code, and then if I just write function 1, it would print that line out exactly the same because that function is being called upon. And it means I only need to write this once. I don't need to replicate it, which means if I get it right once, I'll get it right every single time. That's why we use functions. Now, the easiest thing to know is, the easiest thing to get wrong or forget to do is to define them. So make sure you define your function with the word def. And remember the brackets and the colon. Now, the brackets, within those is what goes your parameters, basically the data that's going to be used within your function. So if you're not sure about that, don't worry too much, but the parameters are the information that's going to be used in your function or the data you want to use in your function. Right, so parameters and arguments are the data, or is the data that's going to go within your function. It's the same thing, but it's basically the thing that goes in the bracket. So when I define my second function, which I'm calling function 2, I'm going to say that the parameters, the data that's going to go within my function, is going to be the names. Now I'm going to ask people to enter their names, right? Oh, sorry, I could ask people to enter their names, but in this case, I just want it to print name is and then plus names. Now what that means is I can run the function, which will run this same thing over and over again, this bit, but I can change the data, the names, I can change them up. So look, if I change the names and I decide what I want them to be, like in this case, if I make the name Jim, it'll print my name is Jim. If I change it to say Big Shaz, the next time I run my function, it'll print name is Big Shaz. And then the last time, look, I run my function exactly the same way, but with the parameter Bob, instead of just leaving it as an empty bracket, it then prints Bob. So it runs the function, but the parameters let me change the data that is used within that function. So that's how we end up with name is, and we can just change the name in the function without having to rewrite the code over and over again. That's why parameters are useful. Right, the first example is that I wanted to show you is this. This is the sort of thing you're going to get in your test today. So Taylor is writing an algorithm to record the results of an experiment. Taylor needs to be able to enter a numerical value which is added to the total, which initially starts at 0. Every time she enters a value, the total is outputted. So every time started, the algorithm repeats until the total is over 100. Write an algorithm to implement. So, first thing we need to do is we need to break down what we need to do. My advice is, at the side of your question paper, literally just bullet point what the program needs to do. Alright, so list what you think the program needs to do. That then just helps you identify, right, what stuff do I actually need to include. The first thing it says it needs is it starts at 0. The clue's in the name. This is me making my total start at 0. Alright, what I then want to do is do a test that loops, which is why I use a while. So it's a looping test. While the total is less than or equal to 100, because it says until it is over 100. So while the total is less than or equal to 100, I want to basically ask for a number. Alright, I'm going to take the total and add the total to the number so it increments, it's going up. So I'm going to keep adding to the number until it gets over 100. So this is how we make it add to the number. So this is basically to stop it from just being like 1 every time. We're going to do 1 and then it goes to 1 plus 2. And then if I add 7 in next time, it'll go 3. So then the total for those two will be 3. So then the value for total will be 3. And then next time, 3 plus 7, if I enter 7, and then the next time, so the answer to that will be 10. Then the next time, if I do I enter another number, my number will start at 10 plus whatever I enter again here. So if I do 70, the next time the value of the total will be 80 because the number I've typed in. And you get the idea. So that's how it increments. The important thing to remember is this: always print your total, because it says really clearly enter numerical value. Every time she enters a value, the total is output. Alright, so bullet point first. So today's test, bullet point what you need it to do. So at the side, bullet point the things you need to do. Then at the side of those bullet points, just write the order in which you think those things need to happen. Alright, 1, 2, that should be a 3. And then have a go at programming it. Now, if you don't know how to do something, it's fine. Don't worry. Just write it in English and move on to the next part. You will not be better off leaving a gap. You're better off having a good go at every bit you can do, and any bits you can't do, just write it in English. Don't worry about it. Pseudocode and English is fine. Right, the next one is just the same sort of thing. You can see the program needs to perform the following task: input a number for the user, double the number, and print the result. Repeat it until the number entered is less than 0. So look, my test is while the number is less than 0, less than or equal to 0, it should actually just be less than 0. I think I made a mistake there, but I want you to ask for a number again. So ask the user to input the number and then basically print or output the number times by 2, because it says the number needs to double itself. So I'm going to times it by 2 and then print the result. So we print the number out. That's why we're printing. And then we're going to keep asking until somebody enters a number that is less than 0. So ignore that bit, it should be there. As soon as somebody enters a number that is less than 0, that will keep repeating. The minute I type in -1, it'll stop and that program will end. So again, just look at what I asked step by step, what we were thinking we needed to do. Alright, break it down, bullet point at the side. So do your bullet points, right, what 4 things, 3 things, whatever does my program need to do, and then just bullet point them in order, and then program them in your gap as best you can. So if you need it to loop, you're going to need a while, or a for/i in range. If you're only doing it once, you know you need an if. So if I didn't need it to loop, if that bit wasn't there, if it didn't say repeat, an if would be absolutely fine. Alright, but because it says repeat, we can't use an if. So because of that repeat, we can't use an if. It's got to be a while. Alright, so just bullet point it, then order your bullet points, and then try and program as best you can. Right, big question here, but basically it's about car dealership selling electric cars, and it's trying to work out the battery charge and the percentage left until it reaches full capacity of the battery. There's a lot to go on here, but we need need to start, as we always do, by identifying what we need it to do. First thing it's got to do, it's got to ask the user for their battery charge. So this is a bit here. So I'm asking the user to enter their battery charge. Now it says it outputs full if the battery is 100%. Okay, so that's my first test. So if the battery is at 100% or is equal to 100, notice the double equals. That means is equal to. 1 equals sets the value of a variable. 2 equals tests it. If the charge is equal to 100, then print full. Right? For everything else, we do the next part of the program. Okay, so we've now done these first 2 bits like that. The next part of the program then, I'll do that in purple so you can see it. Calculate how long the battery would take to charge, because look, it takes basically 10 minutes per percentage. So first thing we need to figure out is what percentage we need to charge. So it'll be 100 because 100 is full minus whatever the person types in, and then we're going to times it by 10 to get the number of minutes. Look, because 10 minutes per percent. All right. Now, it says that we need to then output that in hours and minutes. If you can't do that, and like all of it, then just print it in numbers, or even just write print hours and minutes. It doesn't make any difference. But the way we do it is using our friends div and mod. So the first one, the total number of hours is how many 60s fit into the time. All right. So 60s into the time. Yeah. The 60s into the time tell us how many total hours fit in. All right. Now let's just say there's 110. If it's 110 minutes, right, that means there is only one full 60 that can fit in. So the hours, if we did that div, would be 1. But that leaves us a number of minutes left. In our case, that'd be the remainder or mod. And the mod would be 50. So if we said that it was 110 minutes, that would give us 1 hour and 50 minutes. And that's how it'd work. And that's why then we print the hours and the minutes off at the very end. Now that one would be about 6 marker, 7 marker. So if you couldn't remember div and mod, you'd lose 2 marks. So do the rest that you can do. And then just write remainder, 6 remainder, or 110 minus 60 remainder, whatever it is that makes sense to you. Write it in a sentence. It doesn't make any difference. Just bullet point that bit and then move on to the next bit you can do. But everybody should be able to print it, the result. So if it's this bit you can't do, well then just bullet point and say what you think it should do and do it like that. Don't worry if you can't do something. Just move on with the bits you can and write what you want to happen ideally. Alright? Remember to take your time, bullet point each of these parts,